Hello everyone and welcome back to today's lesson. We're going to explore the positioned sketch tool, one of the most important sketch creation methods in CATIA. You'll learn how to control sketch origin coordinate axis orientation and custom sketch positioning for professional parametric design. So let's get started.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate.
Hello everyone. In this lesson, I want to talk about a tool called Positioned Sketch. So far, you have learned that whenever you want to go to the sketch environment, you first activate a tool called Sketch. After activating the tool, you use it on one of the main planes or a flat surface of the existing body or a created plane. Now let's examine one of the main planes. For example, consider the YZ plane. I set the view direction perpendicular to this plane. This plane is now in orange. Look, this plane has a coordinate center. The intersection of this plane with the other two planes is the coordinate center. Pay attention to the main coordinate axis. You can see the two axes Y and Z. These axes indicate the positive direction with letters. So, on this plane, there is a coordinate center and the positive direction of the axis. Now I click on the plane that I have offset from the XY plane to make it orange. I set the view direction perpendicular to it. You see that plane 1 is exactly on the XY plane. Pay attention to the main coordinate axis. The positive direction of these axes is also indicated on them. So, this plane also has a center and positive direction for the axis. Now I click on the blue surface of the existing part to make it orange. With this surface, I enter the 2D sketch environment. You see that in the sketch plane, there are two main coordinate axes. The coordinate center is the intersection point of the H and V axis. With these two axes, the plane is divided into four regions. The positive direction on both axes is indicated by an arrow. I return to the 3D part environment. Now I enter the 2D sketch environment with the green surface. In this plane, again you can see the coordinate axis and the coordinate center. Note that in the sketch environment, any shape drawn must have a specific position in addition to size. Positioning on the plane can be done using dimensioning relative to the coordinate center and the direction of the axis. So far, when we selected a plane to go to the sketch environment, we had to use the coordinate axis of that plane. This means that the plane already has its own center and coordinate axis. But what should we do if we want to have a plane with a specific center and axis? Here we use a tool called Positioned Sketch to define a dedicated plane. With this tool we define a flat surface, center and axis with their direction. This tool is next to the Sketch tool. I click on this tool to open its settings window. This window has 3 sections. The first section of this window is called Planar Support. In this section, we define our desired flat surface. This section has one option. The name of this option is Type. In front of it, there is a box and a V symbol. If I click on the V symbol, you will see the second state of this option called Sliding. If the sliding state is active, this tool performs exactly like the Sketch tool. I activate the positioning state. Below that, there is a reference. In front of it, there is a box that currently says no selection. In this box, I need to introduce a flat surface to the software. Or I can right-click in it and define a plane. So far, the function of this command is similar to the Sketch tool, that is defining or introducing a flat surface to the software. But from here on, we specify the coordinate center plane and the coordinate axis on the selected plane. I select a plane called plane 2 that is parallel to the green surface. You see that the name of this plane is written in the box in front of the reference option. This plane will be our drawing plane in the Sketch environment. The second section of this window is called Origin. Here we define a point on the selected plane as the coordinate center. This section has one option. Again, its name is Type. In front of it, there is a box with a V symbol. I click on the V symbol to open its drop-down menu. You see that 7 different states are available for defining the coordinate center. The first state is called Implicit. In this state, when we consider a plane as a sketch, the software automatically selects the coordinate center based on the local coordinate system of the specified sketch plane. We are not involved in selecting the coordinate center. For example, if the XY plane is selected and the implicit state is active, the software selects the point 0, 0, 0 as coordinate center. If a surface of the existing part is selected, the coordinate center will be derived from the internal system of that plane. If a defined plane is selected, the coordinate center will depend on that plane. The second state is called part origin. In this case, the sketch origin is exactly equal to the main origin of the part. In this case, the sketch is no longer dependent on the selected surface of the part. Instead, the coordinate center is dependent on the overall coordinate system of the part. The third state is called projection point. In this case, we select a point. The solver projects that point onto the selected surface and recognizes the resulting projection as the coordinate center. The fourth state is called intersection of two lines. In this case, we select two intersecting lines. Now the intersection point relative to the selected plane may have three states. First, both lines are on the same plane, so the intersection point falls on the plane and will be the coordinate origin. Second, the lines are not coplanar with the selected sketch plane, or the two lines are parallel to each other. The solver will give an error. In the third case, the lines intersect outside the selected surface. In this case, the solver uses the intersection of infinite lines mathematically. But still, that intersection must be definable on the sketch plane. Important note: in sketch positioning, we work with an infinite plane. The fifth state is similar to the fourth state. The sixth state is called middle point. Here, by selecting an edge or line, the middle of it is considered as the origin. The seventh state is called Barycenter. Here, by selecting a bounded surface, the middle of it is considered as the origin. Note that this state depends on the geometry of the selected surface. Now here I selected an infinite plane. If I set the state to Barycenter, I cannot click on the plane. I click on a surface parallel to it. The center of this surface is projected onto the plane. Note that even if the bounded surface is perpendicular to the plane, it is still acceptable. The first section is called Orientation. In this section, we define the horizontal and vertical axes and their positive direction. When you enter the sketch environment, you have a horizontal axis and a vertical axis. These two axes have positive and negative directions. Note that here the two selected axes will be perpendicular to each other. If we want our axes to be non-orthogonal, we must use other methods like the coordinate system tool. These two axes divide the plane into 4 geometric parts. All dimensioning is done relative to these axes. The software creates these axes in 9 different ways. The first state is called implicit. This method is like determining the origin, and based on calculations, the software creates the axis itself. The next 3 states specify which coordinate axis the horizontal or vertical direction should align with. Look at the bottom of this section. There are 2 options called H direction and V direction. Currently, the H direction state is active. This means that we are currently working on the horizontal direction in the type section. First, pay attention to the main coordinate axis. The horizontal direction on that axis is X and the vertical direction is V. The H direction option is active. I set it to the X-axis. Pay attention to the horizontal and vertical axis. The H-axis is now both collinear and oriented in the same direction as the X-axis. I set it to the z-axis. Now the h-axis is both collinear and oriented in the same direction as the z-axis. I activate the V direction option. I set it to the x-axis. You see that the V-axis of the sketch plane is collinear and oriented in the same direction as the x-axis. The last three options are called reverse H, reverse V, and swap. With the first two options, I change the positive direction of the selected axis in the sketch. Now the V direction is active. I click on reverse V. You see that the positive direction of the V-axis in the sketch plane has reversed. With the swap key, the horizontal and vertical axes change their position together. One of the options in the type section is called component. With this option, we define the H and V axis of the sketch numerically and vectorially, not by selecting a geometric reference like an edge of the body. The next option is through point. By selecting this option and determining a point, the software rotates the H or V axis in the sketch plane so that they pass through this point. Note that whether the H-axis passes through the point or the V-axis depends on which axis is active. The next option is parallel to line. By selecting this option, the H or V axis in the sketch plane is rotated so that to be parallel to our line. The next option is intersection plane. Here the software finds the intersection line of the specified plane with the sketch. This line is considered as the horizontal or vertical axis depending on which one is active. The last option is normal to surface. Here you select a plane or surface. The software calculates the normal vector of this plane or surface. It places the vertical axis of the sketch perpendicular to this surface. The horizontal axis is automatically set perpendicular to V-axis on the sketch plane. Keep in mind that the selected surface must be such that the V and H axes lie on your plane. Otherwise, you will encounter an error. Very well, today's lesson ends here. I hope it has been of interest to you. Good luck until the next lesson. Goodbye.
Let's build the future.